This presentation, we're going to talk about types of chemical reactions. And there are four major types of chemical reactions, and one fifth one we'll be talking about later too. So synthesis is the first type, decomposition, single replacement, and double replacement. So let's take a look at synthesis first. This is the definition. It's a reaction in which two or more substances combine to form one product. And by substances, if you remember way back to the first unit, it is either an element or a compound. Those are pure substances made of one type of thing. So there's a word equation right here. This is a synthesis reaction of a word equation. Chlorine gas and sodium metal yield sodium chloride. So I'd like you to, on the accompanying Google slides, write down the reaction into an equation, a chemical equation, and then come back and I'll show you how it's done. Okay, please make sure you've done that chemical reaction. So we're going to do chlorine gas. So first, chlorine. It's a diatomic, so it comes in as a pair. It's a gas. And then sodium. Sodium is a solid at STP. I'm going to leave a little space in front of each element just in case we need to put a coefficient there to balance it. It's going to make sodium chloride. That's also a solid, as it says it right there. All right, well, we can see on the left side, on the reactant side, we have 2 chlorine, so we need to balance that with a 2 in front of the NaCl. But now we have 2 sodium on the product side and only 1 on the reactant side, so we can put a 2 in front of this. All right, so we can see here we've got 2 different substances, right? We've got chlorine and we've got sodium. And they're coming together to make one thing. They're synthesizing or making one product. And that is a synthesis reaction. Synthesis means to come together. Here's a general equation for a synthesis reaction. All right, which one of these do you think are synthesis reactions? You can pause the video and think it in your head. All right, so one of those examples is what we've already talked about. And you can see that this is number 1 and number 4. They have 2 different substances coming together to make one substance. All right, so we talked about synthesis reaction. Let's talk about decomposition reaction. A decomposition reaction is the opposite of a synthesis reaction. Whereas synthesis, substances were coming together, a decomposition reaction is when a compound breaks down into simpler substances. Those simpler substances could be either elements, or they could be smaller compounds, or they could be in elements, a combination, like an element and a compound. So let's take a look at one of those. So liquid hydrogen dioxide breaks down into liquid water and oxygen gas. So, again, please write out the chemical equation for this on the appropriate location of the Google Slides document. And then come back here and I will show you how it's done. Okay, so liquid dihydrogen dioxide. So dihydrogen dioxide means we have 2 hydrogen atoms and we have 2 oxygen atoms, and it's a liquid, so we're going to put an L, and it breaks down into liquid water, H2O, and oxygen gas. Now oxygen is again a diatomic. You should look up what the diatomic elements are and memorize them, because when they're by themselves they always form pairs. All right, so is this balanced? No, it is not. We have 3 oxygen on the product side and 2 on the reactant side. And so we need to figure out how to balance this. If I put a 2 in front of this one, we know that the oxygen has to come in pairs, so we see there's an odd number of oxygen atoms right there, and we need to have it come in pairs. Now we've got 4 hydrogen on the product side and 4 oxygen on the product side as well. So if we put a 2 in front of this, now we've got 4 on both sides. All right, so the decomposition reaction, you can see that the dihydrogen dioxide, or otherwise known as hydrogen peroxide, has broken down into 2 separate things, the water and oxygen. Here's the general equation for a decomposition reaction. All right, so we've done decomposition. Well, actually, no, first of all, let's practice. So which one of these is a decomposition chemical reaction? Pause and see what you can do. Okay, if you've answered questions 2 and 4, then you are right. Those are compound breaking down into smaller substances. In this case, they are elements. All right, so we've done decomposition. Let's go and look at single replacement. So this is a reaction in which an element replaces a less reactive element in a compound. So here's an example. Again, let's pause and try to figure out how to write out this reaction. All right, so aqueous hydrochloric acid and solid magnesium go to make dissolved magnesium chloride and hydrogen gas. So first of all, hydrochloric acid, you can find that on your reference tables on the common acids and bases. I think it's table K or L. I cannot remember off the top of my head. We could just pull it up. How about we do that? Common acids, table K. So hydrochloric acid is the first one here. It's HCl, and it's aqueous, which is what we would like. So the aqueous hydrochloric acid. HCl, aqueous, it means it's dissolved. And solid magnesium, so MgS, goes to make dissolved magnesium chloride. Magnesium chloride is MgCl2, and it's dissolved, so that means it's aqueous. And then hydrogen gas, and again, hydrogen is a diatomic element, and we're going to put it like this. Now we need to balance this. We see that there are only one hydrogen in this on the reactant side, but 2 on the product side. I'm going to put a 2 in front of here. That also takes care of the chlorines. And actually, we are done. That is balanced. Okay, let's move on and see the general equation. So you can see here that A is replacing B. It's kicking B out of the compound, and it's taking its place, and it's a partner now with the X. I would normally do a demonstration here of the single replacement reaction. All right, so which one of these is a single replacement reaction? You're looking for an element that has been kicked out of a compound and is now by itself, and the one that was by itself is now inside the compound. So pause and figure this out. If you said 1 and 3, you'd be correct. You can see that zinc has replaced copper in the first one. It has kicked copper out, and it is now inside the compound, right? And in the other case, you can see that the magnesium has kicked hydrogen out. And that was our example before. Okay, double replacement. Let's take a look at this. This is a little more complicated than the single replacement, but not really too much. The chemical reaction is when ions are exchanging places. So the ions exchange places in two compounds. So let's take a look at an example. Here you go. Let's write this out on your Google Slides in the appropriate spot, please. Okay, lead 2 nitrate. Lead 2 tells us that we have, it is a 2+ charge on the lead. So we need Pb. The nitrate ion has off of table E, has a single charge of -1. So we need 2 of those, plus sodium iodide, NaI. Notice I'm leaving spaces still for coefficients if I need them. They're going to change. Now we're going to have lead 2 iodide, so Pbi2 plus sodium nitrate. So now we're going to have NaNO3. And we can, we need to put these aqueous. This is going to be a solid S. Sodium is, yep, they are both aqueous. And let's balance this. We have 2 nitrate ions on the left side, on the reactant side, and only 1 on the product side with the sodium nitrate. I'm going to put a 2 in front of here, and then we're going to put a 2 in front of here, and now we've got this thing balanced. Here's the general equation. You can see that A has switched places with A is with B, now A is with D. Yes, it's switching places with C, I guess, in this case. One way to see this is you can see that the names switch. So lead nitrate and sodium iodide are now lead iodide and sodium nitrate. You can hear that in the description. Okay, so here is some practice for you. Decide what it is. If you said these, you would be right. So hydrogen is switching places with magnesium in the first one. And in the second one, it's doing the same thing. It's hydrogen and magnesium switching places. So those are the 4 main types of chemical reactions. The last type of chemical reaction I want to talk about is a combustion reaction. Combustion reaction occurs between a hydrocarbon and oxygen to produce carbon dioxide and water. All right, so what is a hydrocarbon? A hydrocarbon it's a chemical compound that is made of hydrogen and carbon, hence hydrocarbon. And it will combine with oxygen to burn. This is what most things that burn are. You would have, like, hydrocarbons are in wood and plant material. So it's going to make CO2 and H2O. Again, notice I'm leaving spaces for coefficients to balance these equations. Oxygen has to come in pairs, so that means that the coefficient in front of the water has to be an even number. I'm going to put a 2 in front of there and see what happens. Now we have 4 hydrogen atoms, and we have 4 oxygen atoms, so I'm going to put a 2 in front of here, and this is now a balanced equation. The general form for this would be H. And then you would have to put the coefficients based on what x and y are. X and y could be any number that would work for a hydrocarbon. All right, but just remember, if you see carbon dioxide and water, and you see something that's made of hydrogen and carbon and oxygen, then that is a combustion reaction. You can think of, I always think of what are the 2 things necessary for burning is some fuel and oxygen, and so you can see that in this reaction.